Hello everyone and welcome to this edition of Improving Talks. I'm John Ruzick and today we're going to be exploring Azure Container Apps, which is a new service in Azure that is currently in preview. So a little bit of an agenda. So when we're talking container apps, we're talking microservices. So we'll do a real quick overview of a microservices architecture and why that architecture is really taken off and the advantages it provides. In the context of that, we'll talk about what are Azure Container Apps and what solutions does it bring to the table to help provide some ease of use and enhanced capabilities when you're building out that microservice architecture. We'll talk about the different ways you can run containers on Azure. In addition, we'll talk about the different ways you can run containers on other cloud providers. Then we'll dive deep into the features of Azure Container Apps and really highlight the individual pieces that make it such a cool service. We'll talk about pricing and how they're structuring that. And then we've got an exercise, some source code available, and some things that you can walk through along with me during this presentation, or take away and do this sometime later when you find some time. Come back here and wrap up, and that'll be the presentation for the day. So a little bit about me. Like I said, my name is John Ruzick. I'm a principal consultant at Improving Atlanta. I've been with them a little over 6 years. It'll actually be 7 in July. I'm focused on microservices, design, implementation, as well as around our practice of DevSecOps, as well as focusing on the technologies used in that space. Some of the past projects that I've had with Improving, current project is a massive microservice application implementation. I've done migrations to Azure, done integrations with BizTalk, JavaScript, Angular, front end, back end, a little bit of everything while I've been with Improving. Some of my passion projects are a kegerator monitoring application called KegBot. I've got an Alexa skill out there for helping to monitor 3D printers, as well as leveraging my passion for golf, creating a cross-platform app for iPhone, Android, Apple Watch that will hopefully help give you some golf tips while you're out on the course. So let's talk microservices. And this is a typical microservice architecture. You've got your users that maybe on a web browser coming through a web application or a mobile application, and either way those communicate through an API gateway to many different individual services. And each one of those services is not only in charge of providing the application functionality and business rules and logic, but ideally it also manages its own entities, its own data. And so splitting things up this way really can create some complexity, but it also really simplifies things when it comes to ease of deployments, ease of development, ease of testing, ease of scaling, right? So if you notice on this diagram here, all of our different services, our identity service, our inventory service, our ordering service, our customer info service, they can be written in any language because they're individual services and individual applications. They really can be written in anything. So if you've got teams that are in charge of a certain piece that are really versed in Node.js, they can write it in that. Or if you've got some .NET developers, we'll write a service in .NET. Similarly for backend data stores and databases, sometimes you have services that really need a relational data store or SQL Server. But you've got other services that maybe work better with a NoSQL database like a MongoDB. And with these microservice architectures, you can use really whatever backend database that you want per service and build the best solution for each individual service without tying a huge application into a single architecture or platform. And then what ties all of these together is an asynchronous message platform. Now, there are absolutely cases where you would want to do direct service-to-service invocation, but this async message platform really decouples all of these services and provide some functionality to where your application can even still function if one of these services is offline or having some issues, right? And your message broker can determine what's happening in some of the other services, store those messages, and then when that service comes back online, it will pick up those messages and keep on rocking. So that is a huge benefit of having a microservices architecture. So what does a typical microservice stack look like? So you got your application code, I mentioned any language, and then you containerize that. I say Docker here, but there are several different container technologies, but Docker is kind of the industry leader. So you'll package up your application code into an image or a container image. You'll publish that container image to a container registry. In addition, if you're going to deploy to Kubernetes, you might have a Helm chart museum that is a set of Helm charts that apply configurations as well as defining what image to pull when you deploy that application. And then you'll deploy that to a Kubernetes cluster. And Kubernetes is a container orchestrator that will take care of scheduling and moving those pods, which are a container of containers, onto different nodes. And it can handle scaling and load balancing and a lot of features that are pretty amazing and really cause this whole microservice architecture to work, right? Downside of Kubernetes is it can be complex, and you've got to manage these nodes and the infrastructure and Ingress and set all that up. And there's some complexity to that. So in addition to your application running in your Kubernetes cluster, you'll connect to some shared dependencies. And these are your databases, your relational databases, your NoSQL databases, as well as your message broker, RabbitMQ, Azure Service Bus, and Apache Kafka, things like that. And then you might have caching mechanisms, Redis cache, Memcached, or you'll connect to an Azure Redis cache instance. And those live outside of your cluster, but are services that then your application will connect to and leverage. So what are Azure Container Apps? And how do they try to simplify things and provide some added value as you're developing a microservice application? So Azure Container Apps is a fully managed serverless container service for building and deploying modern microservice apps at scale. It's built on top of Kubernetes, and it was announced here pretty recently at Microsoft Ignite in November of 2021. So you can think of this really as a layer of abstraction on top of Kubernetes. So serverless Kubernetes. Big note here, and I'll mention this multiple times, as of this presentation, February 2022, Container Apps is currently in preview status. It has a lot of bugs, limitations, definitely not general availability, but still far enough along that I think diving in now and getting a familiarity with it is highly valuable. So at a high level, some of the features and capabilities. So deploying containerized app without managing complex infrastructure. There you go. One of the big complexities of Kubernetes is managing those nodes and all the infrastructure and networking. This abstracts that away and takes care of that for you. Again, code in any language or framework. If you've got it in a container, it will run. Native support for distributed application runtime, also known as Dapr. This is a framework that they've built out a lot of the utilities and tools that enable microservice communication and abstracted that out so that you can just call invoke methods to invoke other services, integrate with pub/sub mechanisms, and we'll talk about this a little bit later. Dynamic scaling based on traffic, so the amount of traffic volume coming into your cluster, or Kubernetes event-driven autoscaling, KEDA. So this is a scaling mechanism where you can set up all sorts of different metrics that will enable you to scale. You can look at things like how long is a RabbitMQ queue, right? And scale based on that. And we will see all of that in the exercise as well. Built-in HTTPS ingress. It has traffic splitting for blue-green deployments, secure environment variables and secret storage, native integration with log analytics and app insights, and has the ability to scale to 0 for those instances where you can tolerate having a container offline, but then you aren't billed while that container is not actually up and running. So let's talk about running container workloads on Azure. So there are lots of container hosting options within the Azure cloud. So Azure Container Apps, obviously we're talking about it today, but you could also do this natively on virtual machines. So run container workloads on a Linux or Windows VM. Again, complexities there. You've got full control, but now you've got to manage patching and upgrades and all of that for a VM-based solution. You've got Azure Container Instances. These are serverless container hosting environments, usually for single containers. But another benefit here is this can be used as a hybrid scale-out for an Azure Kubernetes service. If you need to expand some of your capacity, you can expand out to running containers in ACI. There's Azure App Services, where you can run Azure Web App for containers. You've got an Azure Kubernetes service, as we've talked about, and we'll talk about a little bit more. Azure Service Fabric, Azure Batch, Azure Red Hat OpenShift, and another preview feature is the Azure App Service multi-container app. And so this gets closer to microservices in app service, but without some of the features like Dapr and Kita autoscaling. However, again, still in preview, so really not sure what direction they're going to go as these services kind of get fully built out. So let's talk Azure Kubernetes versus Azure Container Apps. So this diagram kind of shows how Azure manages and thinks about Kubernetes. So you have an Azure managed control plane here in the middle, and you don't pay for that. That is completely Azure managed. And then you've got your customer managed nodes. And each node has the different Kubernetes features in it, the kubelets, container runtimes, Azure containers, and kubeproxy. But those nodes then are provisioned and maintained by you. So the Kubernetes API or scheduler, as I mentioned, is provided and managed by Azure. But then you provision n number of always-on VMs as worker nodes inside the cluster. Now, these worker nodes are part of a VM scale set. So you can dynamically scale up and down not only the pods that are running, but the actual number of virtual machines that are deployed in your environment. So you can control cost in that way. The costs are based on the size and specs of the VMs provisioned in the cluster, and then how long they're running. So if you've got 3 VMs and I want a 3-node cluster up all the time, but my workload overnight is a little bit less, you might be able to scale down the number of pods running, but you're still paying for those virtual machines that have been spec'd up to handle your peak workloads. And you're in charge of configuring and managing Ingress, scaling, patching, upgrades to those nodes, etc. Let's compare that to Azure Container Apps, where instead of creating a Kubernetes cluster, you create an Azure Container App environment. And then your apps are deployed as services. You can think of these in Kubernetes terms as pods within that environment. It is completely Azure managed. Ingress, scaling, patching, etc. Now you configure the scaling rules, but spin up, spin down, all of that is handled by Azure Container Apps. And it's usage-based pricing based on 3 factors: the amount of CPU provisioned for your pod, the amount of memory provisioned for your pod, and the number of HTTP requests that are coming through the environment. So quickly, let's touch on container hosting options in the other cloud platforms, AWS and GCP. I know there are other cloud platforms in addition to that, but we'll focus on the big 3 for now. In AWS, they have a lot of options as well. I'll highlight the top ones. AWS Fargate, this is very similar to Azure Container Apps, a serverless Kubernetes type environment that allows you to run microservices. There's the Elastic Container Services, Elastic Kubernetes Service. Again, your full, in your control Kubernetes service on AWS. They have a Red Hat OpenShift service as well. You can run these just like on Azure VMs. You could run these on EC2 virtual machines in AWS, and AWS App Runner is another service. They also have about 50 other services that ancillarily tie into running container workloads in AWS. So a lot of different options, with Fargate, as I mentioned, being the closest analog to Azure Container Apps. So in Google Cloud, you've got Google Compute Engine, which is virtual machines. You've got Google Kubernetes Engine, again, fully self-hosted, fully hosted Kubernetes that you manage. But then there's Google Kubernetes Engine with autopilot mode. And this is their version of serverless Kubernetes, where you just manage the application and pods. They take care of Ingress and actually managing the nodes. So it makes sense here. Google is the primary partner for the Kubernetes foundation and that product. So really embracing Kubernetes as the container hosting platform within Google Cloud. So let's do a deep dive into some of those features that I mentioned for Azure Container Apps. So one of the big ones here is the support for revisions. So this has built-in support for routing traffic to multiple versions of an app, sometimes also known as blue-green deployments. In addition, it can also traffic split on some percentage other than 100% and 0%. So you could do kind of a red-green or a simulated almost feature flag type release by redirecting, say, 80% of your traffic goes to the original revision and 20% goes to the new revision. And so based on customer feedback, based on analytics, you can see that, okay, this either new feature or new performance enhancement we've released in revision 2 actually is working. We don't see a lot of bugs. We aren't getting a lot of negative feedback from customers. Let's go ahead and do a true cutover to revision 2. I mentioned earlier Dapr support. So again, this is distributed application runtime, which greatly simplifies the development of common microservice complexities. Things like service-to-service invocation, pub-sub messaging, event processing, observability and tracing, state management. Those type of things that in a microservice architecture you would have to kind of build out yourself. Dapr is a great way to handle that and remove that complexity from your plate and just leverage something where this has already been solved. The other huge advantage of Dapr is that because it's been abstracted, or these different microservice complexities have been developed and abstracted, you can switch quickly between the different back-end stores or features that enable these without changing your application code. For example, pub-sub messaging. In our example today, we're going to use Azure Service Bus. But once I've got this configured, if I wanted to change from Azure Service Bus to RabbitMQ or an Apache Kafka or something like that, all I have to do is change a configuration file and redeploy. I don't have to rewrite all of my application code to now point to this new service. The pub-sub component of Dapr can work with any number of backends. You just tell it which one. Observability and tracing. This will natively work with Azure App Insights to display tracing data and track requests through your microservice application. State management, again, similarly, if you're going to try to store state, you can point Dapr at Azure storage accounts or an NFS share, anything you want, just reconfiguring a config file, and you don't have to change any of your application code to leverage state management. It's a really powerful tool that's natively built in and supported with Azure Container Apps. I've mentioned a couple times logging and monitoring. The activity within Azure Container Apps, including container logs, are logged to an Azure Log Analytics workspace. It also natively integrates with App Insights for that observability and request tracing. So some of the metrics that get stored into the log analytics: container startup shutdown. So you can trace as containers come up, go down, as things scale out or scale back. Container exceptions, if you've got some problems or some issues or you're catching exceptions inside your containers, you have visibility to those in log analytics, as well as then performance and utilization counters for those containers. Talked about Kita before. This is one of the most powerful features that I've found when using Azure Container Apps. Again, it's Kubernetes event-driven autoscaling. And native Kubernetes allows scaling based on kind of simple metrics like CPU and memory utilization. But Kita expands the types of metrics or events that can be used to trigger scale up, scale down events. So I've mentioned just a handful of them here. There's a link on this slide of all of the different plugins and different things that Kita can monitor. So Azure Event Hubs, RabbitMQ queues, Apache Kafka, SQL Server queries. Write a query to SQL Server, and depending on the results, scale up or scale down. Prometheus metrics, many, many more. One of the examples that I've actually built out for some of my DevOps workloads is using container apps with a scaling rule looking at Azure DevOps pipeline queues. So I've got a single always on container that is a build agent for executing builds within Azure DevOps. It's sitting there always listening for new jobs to come in. But if I kick off multiple jobs using that Kita scaler, I can then spin up multiple containers to run multiple simultaneous builds. And then after a quiet period, it scales right back down to a single running instance. So pretty powerful stuff, and you'll see that and actually have an implementation of that in the exercise when we get to that. So let's talk pricing. So Azure Container Apps, as I mentioned, is completely based on usage, and that's how it's priced, right? And the three metrics are requests, CPU, and memory. So for request, you're billed at 40 cents per million requests into Azure Container Apps, and you get 2 million free requests before you start paying. For resource consumption on your virtual CPUs, if your containers are active, they've got the concept of active and idle usage, right? For your virtual CPU, you're billed at that rate there, some fraction of a cent, and a less fraction of a cent when it is idle. And then you've also got a free grant of 180,000 virtual CPU seconds before you start hitting these billing thresholds. For memory, you don't get a break when it's idle because it's still using that memory when it's up and running, but it's still a fraction of a cent with 360,000 gigabit seconds of free grant every month before you start getting billed. So just as a quick calculation or as an example, a container that is running idle with provision with 1 CPU and 1 gig of RAM, if it's just sitting there running idle for a month, is about $15. If it's not processing anything. If you've got a container that is constantly chugging and processing, it can run you about $70 to run that container. So it's somewhere in the middle there. And again, if you have got a workload that can scale to 0, say overnight there's nothing hitting it, and I don't need this thing on at all, during those hours you aren't billed at all if your scaling rules allow it to scale to 0. So now let's jump into an exercise and see how these things are actually deployed and how they work. So some of the objectives of the exercise are to demonstrate how a container app environment can be created. We'll show how Dapr can be used to abstract pub/sub services in the microservice architecture. We'll highlight some of the Kita features and how it can leverage that via different auto-scaling configurations. will exhibit the logging and monitoring capabilities of container apps. So those are the main 4 objectives of this exercise. So the source code and document is available on GitHub. I've got the link right here. And just a real quick overview of kind of what we're building. So after we spin this up, there'll be a website where a user can decide to publish 1 or 100 messages. When you click a button to publish, a REST API call is made to the front-end service, which is a .NET 6 MVC app. The MVC app uses Dapr to publish messages, and then Dapr is configured to use the Azure Service bus as the backend pub/sub store. Backend service then listens for those messages and picks them up off the topic, does some processing, and then publishes a response message back to that same service bus. And the front end is then listening for those response messaging and then will reply via SignalR to dynamically and in real time update the web browser UI to show what's going on. So if I look at that GitHub link, you'll see here's my Container Apps demo, and you can clone this or download it as a zip and then extract it. I've already done that, and I've got that in a folder here. I'm going to go ahead and open the Word document, and we'll try to do this side by side. Put it over here, and then I'm going to go back to my web browser, and I'll start in Azure, which is the first step in this document. So some overview stuff, some prerequisites for this. You will need an Azure subscription. Free tier is fine. If you've got an MSDN, that's great. If you do a pay-as-you-go, this will probably cost you less than a nickel to run through this entire example if you tear down everything at the end. You'll need the Azure CLI installed, and so here's some instructions on how to do that. And then you'll need the source code downloaded from GitHub. Another overview on what we're building, and we'll jump right into the activities. So the first step is to create an Azure resource group. And from the Azure portal here, I've got my dashboard. Yours will look a little bit different depending on your recent resources or if you've created anything, but you should see up here at the top a button for resource groups. So we'll go ahead and click on that, and then we're going to create a new resource group. I'm going to put this in my MSDN subscription, but you might just have pay as you go. And I'm going to name this Container App Demo. You can name this whatever you want. And you can put it in whatever region you want. I'm going to put this in Canada Central, and that's just because of how this exercise was put together. When I put it together, Container Apps was only available in 2 regions. It is now expanded into multiple regions, but right now I'm going to just follow along with this. If you're following along, go ahead and put this into Canada Central. We'll go ahead and click on Review and Create. We'll see we got validation passed, and we'll go ahead and create that. And exercise 1 or activity 1 is done. All right. So the next step is to create and configure an Azure Service bus. So as we go through this, we're going to be doing things, some of it in the portal, some of it through the CLI, really trying to lock things in and see how things fit together and all the pieces interlock. So I'm going to open my resource group here, the Container App Demo. And within here, I'm going to click this Create button. Now, I can search for Service Bus. Right here, I should get one option, and I'll click on that, and you'll get a screen that looks like this. So go ahead and click Create. Since we've done this from inside our resource group, it should auto-pick your subscription and the resource group name. If it does not, you can select it from this list. I'm going to give it a namespace. Now, this can be whatever you want, but it does need to be unique across Azure because it's going to create a fully qualified domain name. So Container App Demo looks to be available. I'm also going to put this in Central Canada. It's always a good idea to have resources that are going to communicate in the same region just for performance reasons. And I'm going to pick the standard tier. Now we've got to pick standard here because we're using topics, which is only available in the standard tier of Azure Service Bus. We can leave the rest of this as default, and we'll go ahead and click on Review and Create. Now this will take about 60 seconds to spin this up. While we're doing that, in that folder that you downloaded and open the Word document, if you've got Visual Studio Code installed, that is the easiest way, my preferred way to manage this. So from right here in the directory, you can right click and you should have this Open with Code context menu. So you can go ahead and click on that, and this will open the folder. Close the startup page, and we'll go ahead and click on a terminal. I'm going to go ahead and clear this out. And I will navigate into this Deploy Dependencies folder. So I'll just cd Deploy Dependencies. And so we've got this set up and ready to go for our next step, but hopefully, if I go back to my browser, my Service Bus deployment is completed. So we're going to wrap up the steps here for the Service Bus. So go to Resource. You can also get to this, if that doesn't work, back from the home page here under Resource Groups. If you click on your Container App Resource Group, and then you should see a single Service Bus namespace, and you can click on that. So we're going to need a couple things out of here. The first thing is a connection string. We need to know where our Service Bus is so that our application can publish and subscribe to messages. So we're going to click on Shared Access Policies on the left-hand side. And in a real environment, you would create some more secure and locked down permissions, but we're just going to grab the root access key. And when we click on that, we're going to see a primary key, a secondary key, and we're going to grab this connection string. So I'm going to go ahead and copy this to my clipboard and save it to a notepad. So after we've got that and saved that, we're going to click on Topics, and we're going to add a new topic. Now I'm going to change the max topic size to 5 gigabytes. We will not be coming anywhere near that, but I'm just going to set it to the maximum. And then these are absolutely critical just because of the way the application has been written, which are these topic names. So I'm going to go ahead and just from the Word document copy this and paste it here. So I'm going to create a message publish topic and create that. This will only take a second to create the topics. And then I'm going to create another topic that is the message response. And again, set this to 5 gigs and create. So that will wrap up the setup of the Azure Service Bus. We've got our connection string, we've got our 2 topics, and that's all we need to continue on. So we're ready to go to activity 3. So we're back here in Visual Studio Code, and I'm in my Deploy Dependencies directory. Now we're about to deploy some resources to Azure using the Azure CLI. So the first step that we need to do is log in. So I'm going to run the command az login. Actually, while that's running, I will adjust my screen here so you can see the exercises. But what that will do is pull up a login in your browser to where you can pick your account. So I'm using the exact same account that I'm logged into the portal with. So once I've done that, that'll come back and show you what your subscriptions are. So let me clear that out. Let me bring up the Word document here, move this over to this side, and try to adjust things so you can see what's going on. So we've got this deploy dependencies PowerShell script. So I'm going to run that right now. Deploy dependencies. And this is going to walk through and prompt you for a few things. So the first thing is going to be that resource group name. So Container App Demo. The second thing is going to be a resource prefix, and this can be anything you want, preferably just a short string that's going to prefix any of the resources that we create in Azure. So I'm just going to say cont app demo. So this is going to go through, and it's going to create our resource group, which has already been created, which is fine. It knows that it's already been created, so it's fine. It's then going to create this log analytics workspace. And all of the code for this you can view in this deploy dependencies PowerShell script. But the key thing here is we're just running AZ commands, but the key thing that you want to see here is this last step where we deploy the environment. And we're going to use a bicep file to deploy this environment, passing in some parameters like the resource group, the location, the environment name that we want, log analytics workspace, the client ID and client secret that we'll get after it's been created, as well as an application insights key. And so it'll dynamically grab all of these as it creates these resources and pass them in to this environment file, which is this bicep file that spins up an Azure Container Apps environment. Now you can do this through the portal, you can do this through an ARM template. We're just using bicep here because we're setting a couple features like this log analytics configuration, the Dapr instrumentation key, which is application insights, and the portal does not allow you to set all of these variables, so you have to do it through a bicep template or an ARM template. Again, this will all get better as it gets closer to general availability. So if I now go back and look at the terminal here, got too many terminals open. Let me close these. So what you'll see is this is all completed, and I've got two things that this PowerShell script has output. And that's my app insights key and my environment ID. And we're going to use these for step 4, which is actually deploying the container app. So I'm going to expand this to just show you, but you can follow through in the Word document. I need to go into my back-end processor and my front-end MVC app and populate these values. So remember, we've got 3 values. So let me go ahead and open the front-end deployment file and the back-end deployment file. Like I said, if you remember, we got 3 values: our app insights key, our environment ID, and then that service bus connection string. So let's start with the environment ID. So I'm going to go ahead and copy this, and in each one of these files where we've put this placeholder kube environment ID, we're going to drop that in. And we'll do that again over here on the front end deployment file. The next step is grabbing this application insights key. We'll copy that and paste that in right there and right there. And then finally, we've got our service bus connection, and that's going right here at this service bus connection string. Make sure we've got these files saved, and that's it. So now in my terminal here, if I clear this out, I'm going to go back, and from the top level in my Word document, we've dropped in some commands here. And so we'll go ahead and copy this and paste that into the terminal. And what you'll see is this command is going to ask for that resource prefix that you created, as well as that resource group name. I'm going to go ahead and run this. So this is actually going to go ahead and then deploy the front-end MVC app. And we'll take a look at that deployment file here in more detail in just a second. after this runs and after I then also deploy the backend. Now, deploying these container apps doesn't take very long. This should go pretty quick. And so it needs to know the environment, and that is all configured in that deployment YAML file. So we've got that deployed. We're going to go ahead and just change this to backend processor and change this to backend. And go ahead and deploy that as well. So let's take a look quickly at one of these deployment files. You'll see it's just a YAML configuration file. And the type is container apps. We already provisioned our Kube environment ID, which is that subscription ID that we got when we deployed the dependencies. Service bus connection string. And then here's our template. And we're pulling a container image that I've already published out to Docker Hub, provisioning some CPU resources. So we've got half a vCPU with 1 gig of RAM, and then we've created a secret ref, right? And so up here under configuration, we've defined some secrets, that connection string and the app instrumentation key, app insights instrumentation key, and then we're referencing those down here when we set these things up. So we're referencing this secret ref, app insights instrumentation key for this environment variable, and then in our Dapr configuration, we're referencing the service bus connection string and setting up some different properties, including what type of component are we setting up, which is the PubSub Azure Service Bus. Now on the front end, we aren't doing any fancy scaling, but on the back end, you'll see that I've got my min replicas set to 0, so it can scale to 0, and our max replicas set to 10. And I've created a service bus scaling rule using Kita that's going to look at this service bus connection string, look at this topic, and it wants that queue length to be less than 5. If this queue length gets beyond that, it's going to start scaling up until this queue length goes below it, and then after some time of the queue length being below this, it will scale back down. And we can see that in action now that we've deployed all of our resources. So that was activity 4. Now let's go to activity 5, which is just browsing this through the portal. So I'll go full screen here and go back to my resource group. If I refresh this, I should see a lot more resources. So we've got our original service bus, we've got log analytics workspace, an app insights environment, we've got our container app environment, and then our 2 container apps. So if I look at the front end, let's start there. What you'll see is I've got an application URL. And if I click on this, here's my application up and running. I was able to connect to it. And I can even, just prove this works, publish a single message. And so we published 1, and 1 came back. Perfect. Everything is working as designed. And so what you'll see is under revision management, I've got a single revision, got 100% of my traffic going to it. So this is where, right from the portal, you can set up traffic splitting or A/B testing and a live cutover to a new revision. So right here from the portal, you can manage the traffic going to different revisions. If I look at this revision, you'll see that I currently have 1 replica running, some information about the container, some information about scaling. You'll see 0 to 1 with no scaling rules. And then my Dapr configuration, Dapr is enabled, and I'm using this service bus as a Dapr component. If I go look at the back end, there's where things get a little more interesting. You'll see this does not have an application URL. It's just a back end, so there is no Ingress. I've disabled it for this service. It's completely a back-end processor triggered through Dapr communication. If I look at the revisions here, this thing, because I do not have any Ingress, I can't traffic split to it, so that's disabled. I'm going to go here to information about the revision. I've got 1 replica running. If I look at my container, here's some information about the container. My scaling rules, you can see I've got a custom scaling rule. And this is another limitation of the portal. That's all you see. You can't see any information about the scaling rule or set this up through the portal with the key to scaler. So I'm sure that will be enhanced as this gets closer to GA. If I look at Dapr, very similar setup with a Azure Service Bus. So let's do this. We'll look at my container demo backend revision, right? Go look at this. I currently have a single replica. So if I go back to my home page and publish 100 messages, you'll see this start counting up. If you remember, we had a scaling rule of only 5 messages in the queue. Well, this is a lot more than 5 as it's going through and processing. So if I look and start looking at the overview of this container, you'll see I now have 4 replicas of this running. And as I come back and refresh this, I should see it increase even further. I've got 8. And so the scaling will continuously double these until it hits the threshold or the limit that you've set for scaling is met. So if I go back, you'll see that I'm now up to 10 replicas, and it will stay here because my max replica count is 10. And so this will start processing and counting up. If I were to publish another 100, this would actually go a lot faster because I've got now 10 integrated. There's some things in the source code just to mimic slow down processing so that it doesn't process these instantaneously. Without that slowdown, Azure Service Bus and Dapr would be able to process 100 messages in milliseconds. So this will go ahead and count up. While that's counting up, we can go ahead and look at some of the analytics. And that is also mentioned here after we've viewed our scaling. We can look at our logging and monitoring. So in our demo app analytics resource, under logs, we'll close this. You'll see we've got this section for custom logs and this container app logs CL. So this is a custom logging table that is provisioned when you stand up a container app environment. And so I've got a query here in the document that we can run, and you'll see all of the data for our containers. So you can see our backend processor controller and all of the different information about these containers that are being published to the logs. Let's go ahead and publish another 100 while we're out here. And you'll see now that we've got 10 replicas, this is going a whole lot faster. So let's take a look at one final thing, and that's our app insights. So you'll see we've got metrics coming in, server response times, different server requests coming through. Depending on how fast this is loaded data in, we can start to look at an application map with our front end and back end with all of our Dapr calls and dive into what's going on here. We can search for all of our telemetry data, and you'll see that these pub sub message response topics, you'll see Dapr is logging information here to App Insights, and through this you can get all sorts of information on logging and tracing of your requests as they're being processed through the system. And you can even look at things like live metrics and connect and all of the different features that App Insights has. If I go ahead and publish another 100, you can start to see CPU percentage, exception rates, incoming request numbers, etc. come through here in the live telemetry data with its integration with App Insights. So hopefully that was informative. If we want to go ahead and tear this environment down, I've listed the steps in the Word document as well. One of the things with Log Analytics is this will go into a soft delete if you just delete the resource group. So it's really a two-step process. If you want to completely close this down, go to your Analytics workspace, delete this, click on Permanent Delete, enter the application name or the workspace name, and go ahead and click Delete. And then what you can do is delete the entire resource group. And that will wipe everything out. So back to the presentation here, let's go ahead and wrap things up. Some of the current limitations and issues. Again, preview service. Many bugs and missing documentation and features that are continuously getting better, but they are still a little ways away from getting this to GA. There's some issues with service name length, shared Dapr components. If you're trying to reference components via the same name, there's problems with that. Region availability is a lot better than it was even a couple months ago. There's a full issues list available on the Container Apps GitHub. Not all Dapr components are supported or documented. In addition, it uses a slightly different YAML configuration syntax than native Docker components. There's no Terraform provider as of yet. You deploy via Azure CLI, ARM templates, or Bicep. And first-class support for CI/CD with GitHub Actions exists, but not yet with Azure DevOps. However, because of the Azure CLI integration, you can run all of your CI/CD pipelines using different tools and tasks in Azure DevOps pipelines as well. So some primary resources here: the main Container Apps repo, Container Apps documentation, information on Kita and Dapr, and then again a link to my GitHub where you can find this exercise. So thank you so much. I hope that was informative, and if there's anything else we can help with, definitely get in touch. Thank you very much for joining, and have a great day.